So Azure SQL Database architecture. We know already Azure SQL Database, it's a highly scalable, it's a multi-tenant and highly available platform as a service, something called PaaS, or some people call it Database as a Service, DBaaS, and it's Microsoft offering as a platform as a service. Basically what this means is Microsoft take care of the operating system, they take care of storage, networking, any virtualization, any physical servers, any installs and upgrades of operating systems and database platforms. They look after the infrastructure and they look after maintenance. So in theory, lots of the database overhead that many sort of traditional database administrators would be used to in terms of looking after their on-premises SQL Server go away. But there are other things then that you need to consider. So an Azure SQL Database allows users to focus solely on managing their data. An Azure SQL Database is divided into 4 layers that work together to provide the relational database functionality to the end users. And this is shown in the following diagram. We have a client layer where our client connections come from. We've got things like ADO.NET, ODBC, SQL, server applications and the like. Then we have got the service layer, which is responsible for the provisioning, billing and metering and connection routing and so on. Now, pay particular attention to this layer. This layer and the functionality it provides is what differs it from an on-premises SQL Server instance. And under that, we've got the platform layer. So we've got SQL Server, SQL Azure Fabric and Management Services. These can get replicated between different servers at the platform layer. And then underneath that, we have the infrastructure layer. Now, if you were to compare on-premises SQL Server architecture, and then other than the service layer, the rest of this architecture is pretty similar. Okay, and the replication done at the platform layer, that is done by Microsoft itself. The end users don't have to perform anything in order to configure this replication. Okay, and it's done by Microsoft to provide business continuity, going back to that DRHA thing we had earlier. If one of the physical servers hosting the database fails, then connections would be made available to the other 2 servers. Let's have a look at these architecture layers in a little more detail, starting with the client layer. Now, the client layer acts as an interface for applications to access the SQL database. Now, the client layer can be on premises, it can be in Azure itself. The tabular data stream is used to transfer data between the SQL database and the application, and SQL Server uses TDS to communicate to applications. This allows applications such as .NET, ODBC, ADO.NET and Java to easily connect to a SQL database without any additional requirements. This client layer can be on premises, it can be in the cloud, it can be up in Azure. The tabular data stream, or TDS, is used to transfer data between the Azure SQL database and the application, and SQL Server will use TDS to communicate with applications, and this is what allows many applications to connect to a SQL database without any additional requirements. Next up, we have the service layer. Now, the service layer acts as a gateway between the client and the platform layers, and it's responsible for things like provisioning the SQL database, authentication of our users and SQL database validation, user authentication and SQL database validation, enforcing security, so it looks after things like firewall rules, and denial of service attacks. It looks after billing and metering for SQL Server databases. You pay for what you use, so they meter your resource usage. It's also used for routing connections from the client layer to the physical server hosting the SQL database in the platform layer. Now, the platform layer, this consists of the physical servers hosting the SQL database in the data center. Each SQL database is stored in one physical server and replicated then across 2 other physical nodes. So there's 3 nodes in total for your Azure SQL database. Now, the platform layer has 2 other components, which is Azure Fabric and Management Services. Azure Fabric is responsible for load balancing, automatic failover and automatic replication between the physical servers. And the management service, this takes care of individual server health monitoring and patch updates. The replication between the physical servers, as I touched on earlier on, that is handled by Microsoft. That's nothing for you as the end user need to configure. And then lastly, layer 4 is the infrastructure layer, and this is responsible for the administration of the physical hardware and the operating system. Now, just a key point to note here, dynamic routing allows for the moving of a SQL database between the different physical servers. So if a hardware fails, we can move it between the different physical servers and the application will know no different. So it allows for hardware failures and load disruption.